Hello everyone, we are from group Make Rise are going to present about the fixed and dynamic memory allocation on first fit and best fit. Okay, so first thing first, let's see what is memory allocation. Memory allocation is a process where computer programs are assigned with virtual or physical memory. So it is to provide a space for the process to complete their task. For example, here we have a RAM and we have process over here. So how computers are going to assign which memory parts to which process? Okay, we have so many process, so computer will undergo this memory allocation process. Okay, now let's look at the memory allocation on fixed memory and dynamic memory allocation. Okay, let's look at fixed memory first. So here for the fixed memory, we have a memory with assigned size. Okay, here we have 25K. So now the process can just enter the memory. Okay. However, for fixed memory allocation, we will have internal fragmentation. Okay, internal fragmentation, it refers to the unused space of the memory. Okay, let's say here for process 2, the memory allocate 25K of memory. However, process 2 only use 5K, which means the unused is 20K. So this is what we call internal fragmentation. Next, look at the dynamic memory allocation. For dynamic memory allocation, the process is going to enter the memory within their size. Okay, like this. Process 1 10K, process 2 5K until process 5 20K. Okay. However, for dynamic memory allocation, they can experience external fragmentation. Okay, what is external fragmentation? Let's see. Okay, we have process 3 exited the memory because it has done its task. So now process 6 want to enter with the size of 30K. Okay, however, process 6 cannot enter because the size allocated here is not enough. Okay, here is 15K, meanwhile process 6 is 30K. So process 6 need to wait for the other to exit, and then only process 6 can enter. That is what we call external fragmentation.
Hello everyone, my name is Lo Wei Chia from Course OS Section 1. Today I'm going to explain about first fit memory allocation algorithm. If an operating system decides to use the first fit memory allocation algorithm, then it will always find from the first free memory block to the last one. It will never find from the middle or last. It's just like when you are driving a vehicle and moving to a parking lot. When you are just entering the parking lot, you will always find a free space to park your vehicle from the entrance, right? You will never find free space from the exit or the middle of the parking lot. Next, if the free memory block has a size that is greater or equal to the job size, then the job is said to be fit to that memory block. If we use the same parking scenario to explain this statement, it is the same theory like you will find a slot that is larger or equal to your vehicle size. If you notice that the slot is smaller than your vehicle size, definitely you will ignore the parking slot and you will find the other parking slot that can suit your vehicle. Last but not least, the job must be allocated to the nearest memory block possible. This simply means that the memory block at the back will never be occupied unless the memory block that is situated in front of it already allocated by the operating system to the job. So now let us move on to the practical part. Let us consider the example given and below. In the table, there are 5 processes to be allocated by using first fit memory allocation algorithm. To allocate the first process, which requires 2 MB of memory, let us have a quick recap on the first fit memory allocation algorithm. So remember, if we always find from the first free memory block, then if the memory block is greater or equal to the job size, then it can be assigned to the memory block. Last but not least, the job must be allocated to the nearest memory block possible from the beginning to the last. So let's see the first process. Is the memory block at the first position greater than the job size, which is 2 MB? The answer is yes. So it can be allocated to the first memory block. Now we move on to the second process, which takes 10 MB. Is the second memory block is greater or equal to the job size, which is also 10 MB? The answer is yes. So P2 can be allocated to the second memory block. Now the third process, which takes 15 MB. We will check is the 4 MB is greater than the 50 MB? The answer is no. So now we move on to try on the second memory block. Is the 5 MB greater or equal to 15 MB? The answer is no. So we move on to the third free memory block. The third memory block has a size of 6 MB and the job size is 15 MB. Do you think 6 MB is greater than 15 MB? No, right? So you cannot allocate to the memory block. Now we move on to the fourth memory block of size 20 MB. Is 20 MB greater or equal to 15 MB? Yes. So P3 can assign to the fourth memory block. Now the fourth process takes 6 MB of memory. So is the memory block size has a size greater than the job size? No. So it cannot be allocated. Yeah, as expected. So now we move on to the second memory block of 5 MB. Is 5 MB greater or equal to 6 MB? The answer is no. So cannot also. We move on to the third memory block of 6 MB. Is the memory block size is greater or equal to the job size? Yes. So it can be allocated. Now the fifth process, which takes 10 MB. Is 4 MB greater or equal to 10 MB? No. So it cannot allocate to the first memory block. Second one, is 5 MB greater or equal to 10 MB? The answer is no again. So cannot. Now we jump to the third free memory block of size 12 MB. Is 12 MB greater or equal to 10 MB? Yes. So it can allocate right after P3. So this is the memory block which all the processes are allocated to the memory block. So this is basically how first fit memory allocation works. It's very simple because it's always fine for the first free memory block to be allocated. If the first one does not fit the job size, then it will move on to the second one, the third one, the fourth one, until the last one. I hope you guys can understand well on this topic, the first fit memory allocation algorithm. Thank you very much.
Hi guys, my name is Luisian and I will be talking about the best fit algorithm. First of all, what is the best fit algorithm? Same as before, as the first fit algorithm, they are both part of the placement algorithm, where the jobs are being allocated inside the main memory, which is the RAM, but different from first fit, where the algorithm will find the first suitable or the first space that is big enough for it to fit in. The best fit algorithm, as the name implies, it will find the smallest holes that it is big enough for it to fit in. For example, look at this picture. Consider this one is the main memory and B is a job that wanting to get into the main memory. As we can see here, B can fit in into just every of the empty spaces here, which is represented by white space, and the orange space is indicating it is being occupied. So if in the case of first fit, it will just go inside the first one because the first one it already fit in, so it won't have to go through another space again to find the best suitable space for it to fit in. But in the case of best fit algorithm, even though it already find the empty space that is big enough for it to fit in, but B still have to go through all the list to find the another empty spaces that might be suitable for it to get in. So in this case, it will proceed to try to get into the second empty space inside the list, and then another one, which is the last one in this case. But all three of the empty spaces is big enough for B to fit into it. So in the case of best fit, it will find the smallest space that is big enough for it to fit in. So the smallest space among these three empty spaces here is 15k. So B will just get into the 15k empty space. With that being said, so in the case of best fit algorithm, you have to search through the entire list in order to get the best fit for the job. So this is an example of best fit algorithm, which is in the situation of dynamic partition. So the table here shows us the jobs that are queuing up, ABC, but they have the different size here, which is 10k, 15k, and 22k. And these are the blocks that are representing the jobs. And these orange bars here actually representing the memory space, and it is now fully occupied by the jobs D, E, F, and G. So after the jobs being swapped out by the job scheduler,
お前はもう死んでいる。何?
So now we have empty spaces inside the memory space. The empty space here will follow the size of the previous job be occupied there. So let's start our best fit algorithm in the dynamic partition. So the first job inside the list, which is A, with a size of 10k, it will have to scan through the entire list. So the first empty space, yes, it can fit in because it is only 10k and the first available empty space is 20k. But we cannot stop there yet. We have to keep proceed until the last empty space. So the second one is 15k and it can fit in too. And the last one, 35k, and obviously yes. So the question is that, which one should we pick? Actually that no matter the partition is a fixed type partition or a dynamic partition, the best fit algorithm works just the same. I have to search through the entire list and then find the smallest space that is just big enough for it to fit in. So in this case, 15k is the smallest among the empty space that is just big enough for A to fit in. So in this case, A will go into the 15k empty space. So now we have only 2 empty space left. Now let's move on to the B. Job B with a size of 15k. You will just have to run through the same procedure again. The first empty space, 20k, yes, you can accept it. And the last one, 35k, and yes as well. So in this case, we will choose 20k because it is a smaller empty space compared to 35. And the last one, 22k. Job C. There is no other empty spaces here, so we will just go into the last one. So there you have it. This is how best fit algorithm works. But the same as the fixed size partition, the dynamic partition also has its own problem as well, where it will create an external fragmentation where the empty spaces here in the 20k, there are still some space between them. It will create an external fragmentation.
Hello and Assalamualaikum. My name is Fatina Shah binti Yusuf. In this video, I would like to present about the advantage and disadvantage of best fit and first fit. First, the advantage of first fit is it is a fastest algorithm because it searches as little as possible, since first fit will start allocate at the first hole if the memory block size is already greater or equal to the file size. Then the disadvantage of first fit is the remaining unused memory area after allocation become waste if the file size is too smaller than the memory block size. This situation can lead to a big internal fragmentation. And then the next file request for larger memory requirement cannot be accomplished. Next, we move to best fit. The advantage of best fit is the memory utilization is much better than first fit, as it searches the smallest free partition for first available, which can reduce the internal fragmentation. But best fit still have its disadvantage because it's slower in making memory allocation, because best fit will scan the list again and again, which takes a lot of time. Every time we want to save a file in a block memory, we have to find a memory block size which has size either similar or slightly more to the file size.
Alright, that is all from us, Mixed Rice Group. In conclusion, we have learned the implementation of the concepts on memory allocation, which includes fixed partition memory allocation and also dynamic memory allocation, as well as the first fit and best fit algorithm in computer system. So our team have tried our best on delivering the most brief explanation in the video and hoping that everyone enjoy our sharing. Thank you.